I was required to take a database normalization class during my CS degree, and frankly, it was boring. Look, here's the deal. There's basically the academic definition of database normalization, and there's how database normalization actually impacts the apps you write. Now, in this video, I will give you kind of a high-level overview of the academic definitions of first, second, third normal form. But really, what I want you to take away from this video is how database normalization and how certain strategies can help you reduce data duplication in your databases and improve data integrity. Basically, just making your web apps easier to work within and more maintainable. So we are talking about database normalization. And basically what that means is you can have a database that's architected in a less or a more normalized way. And the more normalized the database is, the less data redundancy you'll have, so the less data duplication, right? And the more data integrity you'll have, so the more correct the data will be. So generally speaking, normalization good. And the reason for that is you're much less likely to introduce data-related bugs into your application. So there are 4 tiers of database normalization. There's first normal form, second normal form, third normal form, and Boyce, COD, normal form, named after the guys who kind of came up with this system. Okay, so what does that mean? Well, basically, the most important thing to understand is that as the levels go down, your database becomes more normalized. And these names, first, second, third normal form, and Boyce, COD, normal form, just map to some rules, right? So, for example, first normal form might have 1, 2, 3 rules associated with it. That's not actually how it works, so I'm trying to give an example. Second normal form adheres to, let's say, 2 additional rules and all of the rules from first normal form. So 5 total rules for second normal form. Right? Third normal form, let's say, tacks on 1 additional rule, and it adheres to all of the rules from second and first normal form. Hopefully you get where I'm going with here. So third normal form has 6 total rules, and let's say Boyce, COD, normal form tacks on 1 additional rule, right? And then adheres to all of the previous rule sets. So as you normalize your database more and more, you'll be kind of moving down this kind of tier list of normalization. So we talked abstractly about the idea that all of these normal forms have rules. Now let's talk about the actual rules themselves. So first normal form has 2 rules. The first rule is every row must have a unique primary key. And rule number 2 is that there can be no nested tables. Okay, 2 very simple rules. Let me show you what I mean. Here is, well, let's draw out a little database for ourselves. Let's say that we have a table in the database, and the first row, let's say this is a users table. We've got first name, Lane, last name, Wagner, and then age, 17. If in the same table, I have the exact same row, Lane, Wagner, 17, then this table does not adhere to first normal form. First normal form requires that every row must have a unique primary key, which translated out of kind of academic database speak, literally just means you cannot have completely duplicate rows, right? So the simplest way to escape like being outside of any normal form at all would be to just add an ID column. Like if we just add IDs here and we give row number 1 ID 1 and row number 2 ID 2, then ta-da, we're in first normal form. Now there is this second rule, right? There can be no nested tables. I've never actually ran into that in production. Most production databases don't even allow you to nest tables in the first place, so you don't have to worry about it too much. But it really just means you can't, take an entire table and shove it into the cell of another table, which, again, hopefully it just makes sense why you wouldn't want to do that. But again, most databases don't let you do that anyways. Moving on to second normal form. Second normal form actually just has one additional rule. So to be in second normal form, your database must adhere to first normal form. And what additional rule? And that additional rule is that all columns that are not part of the primary key must only be dependent on the entire primary key, not just a part of the primary key. That's kind of word soup. So let's look at an example. We've got our database. Let's say we have 3 columns. We've got first name. We're going to do last name and first initial. So first name, last name, and first initial. And then let's populate the database with some names. So we've got, say we've got 2 lanes. We've got a lane small. We've got a lane brewer. And then let's say that we've got an Allen small. And then the first initial for all of these would be L, L, and A. Okay. Now, this table adheres to first normal form because there's no duplicate rows, right? And no nested tables. It does not, however, adhere to second normal form. And in order to understand why, we have to understand what we mean by primary key. So typically, when you're working in a production database, the primary key, in a practical sense, will just be an ID column. And that ID column will always have a unique ID for every row in the table. That makes database normalization fairly easy, right? But when we're trying to understand database normalization in more of an academic sense, when we say primary key, what we mean is just kind of the smallest number of columns that we can use to uniquely identify a row. So in this case, first name can't be a primary key on its own because there's 2 lanes. Last name can't be a primary key on its own because there's 2 smalls. And first initial can't be a primary key because there's 2 L's. But if we, say, combine first and last name columns together, they are unique together, right? There's only one lane small combination. There's only one lane brewer combination, and there's only one Allen small. So our primary key is going to be the combination of first and last name columns. So with that definition in mind, let's read the rule again. All columns that are not part of the primary key, so in this case, first initial, must only be dependent on the entire primary key, not just a part of it, right? Here's the problem. First initial is entirely dependent on just the first name column. In other words, it's dependent on part of the primary key, not the entire primary key. One way to solve this problem would be to create a new table and to move first initial, the first initial column down here into that second table. And then we would map first name to first initial. And now you'll see we actually have some redundancy down here. Notice that lane being mapped to L only needs to happen once, right? So we could actually remove a row. Cool. Now we have one table with unique data. And anytime we need a first initial, we can look up the first initial for a given name in a separate table. This reduces redundancy, right? We talked about how normalization reduces data duplication and data redundancy. We now have less data duplication. Moving on, we've got third normal form. So remember, a database in third normal form follows all the rules of first and second normal form, but also one additional rule. And that is that all the columns not in the primary key are dependent only on the primary key. Dependent. Let's bust out an example. I'll use the same example as last time. Let's say that we've got lane small. Actually, let's do this. Let's do first name. Do last name. We'll do first initial. The key difference is that this time we'll add at the start an ID column. And we'll even be good database citizens and give some unique IDs. So in this example, the primary key is literally just the ID column. Okay. And then let's add some data. So we need 2 lanes. Lane, do Allen again. And we'll do small, and we'll do Brewer in the middle. And then here we've got L, and A. Whew, okay. Now, notice, this table actually does adhere to second normal form, technically, right? Because, yes, first initial is completely dependent on first name, but first name is now not part of the primary key. So it does adhere to second normal form. I'd argue that it's a pretty stupid academic distinction. Really, we have the same problem. We're duplicating data. So anyways, the way we fix it is essentially identical. We can take this table, create a new one, and strip it down to just the parts we care about. In this case, we don't need last name or ID. We would just map first names to first initials. And the way we're going to do that is by shrinking it down here. We don't need 2 lanes. We just need a lane and an Allen. And move this column as well. Again, remove the redundancy. Cool. Now we have all the same data being represented. Why can't I move that? There we go. Anytime we need the first initial for a first name, we can look it up in this secondary table, right? We've reduced some redundancy and we have a primary ID column. Again, the distinction between second and third normal forms in practice as a backend developer working on databases is fairly meaningless. The idea is basically the same. So Boyce cod normal form adds one additional rule. And that rule is that a column that is part of the primary key may not be dependent on a column that is not part of the primary key. A fun historical fact is that Boyce cod normal form was actually created later, after the first, second, and third normal forms, only after realizing that there is a way for duplicate data to slip into tables, even when a table adheres to all the rules of third normal form. So this additional rule was added. Now, in order for Boyce cod normal form to actually matter, the database actually has to be in kind of a weird and specific state. That's why it wasn't really added till later, when people actually found out that this is potentially a problem. Okay, so what do I mean? Let's take a look at this database we have here with the 4 columns: release year, release date, sales, and name. The problem here is that we have multiple possible primary keys or candidate primary keys, right? For example, we could just have the primary key be the name column, right? Because all of these names are unique. Kiss Me Tender, Bloody Mary, I Want to Be Them, He Got Me, right? They're all unique. Additionally, a possible primary key could actually be the combination of the release year column and the sales column, right? If you take a look, 2001, 100, 2001, 200, 2002, 100, 2002, 200. Those are all actually unique combinations. So that could be a possible candidate key. Additionally, just the release date column could be its own possible candidate key. So again, the thing that sets up this problem for Boyce cod normal form is we have multiple possible primary keys. Now, let's say for the sake of example that we've chosen the combination of release year and sales, right? These 2 columns, release year and sales, as our primary key. Now, the problem is that release year, this column, is fully dependent on the release date column. So we have a column in the primary key that is dependent on release date, which is a column that is not part of the primary key, right? So we're breaking Boyce cod normal form. And if you go back and read the text from second and third normal forms, you'll actually realize that this isn't strictly forbidden in those definitions of normal forms. So we can fix this. The way we fix this is just by making release date not dependent on release year, right? We'll just do release date and we'll just store the month and the day in that column. And if we were sane, we might change this to say release month day or something like that. You get the idea. It's worth pointing out that the distinction between second, third, and Boyce cod normal forms is mostly an academic exercise. In your day-to-day job as a developer, you shouldn't be worried too much about the differences between all of the different normal forms. What you should be worried about is, are you duplicating data? Is there a way I can restructure my tables so that when I update something in one place, I don't also need to update it in another? That will keep your database less duplicated, and it will also keep it more correct because there's less of a chance of you forgetting to update multiple copies of the same data.